All right. Hello and good afternoon. Thanks for joining us. My name is Vladimir Bulović. I'm the director of MIT Nano. And you are in this room going to hear for next 50 minutes or so different updates on MIT Nano. So if you're here for the cookies, just cookies, they're in the back. If you're here to hear us, please keep focusing forward. My pleasure is to introduce you our team. And actually, I'm going to do that in just a moment. First of all, I want to tell you about this community update, because it's not the only one you're going to hear. You're going to hear actually this every month from now till the attendance dwindles down to fewer of you. There is a lot to tell you about what we are doing and why we're doing it. Activities inside the building have been truly out of this world. In the next 50 minutes, we'll just give you an outline of the kinds of things that are happening inside the building. At the same time, when you walk by MIT Nano, you might notice that, for example, the ground level clean room is not very occupied. And it's not, because there's just a lot of space. If we build the building smaller, we would have already been done filling it out. Good thing we are not. And we expect it's going to take about 3 to 4 years to truly fill out every nook and cranny of Nano. That gives us a tremendous opportunity to ask about what's next and what's next we want to do. Already, though, the places that are occupied have tools that the campus never had before, and are also yielding results that the campus has never seen before. So we are extremely excited to share with you some of those during these updates. At the same time, ask your input on the kinds of things we should be considering. Now, MIT Nano is a very big space. We have 100,000 square feet of laboratory space in a 200,000 square foot facility. Those of you who prefer meters, 10,000 square meters of lab space, 20,000 square meters of active facility. That means that we have a tremendous amount of opportunity to support many communities across the campus. So what's the easiest way to describe this? Well, the easiest way to talk about MIT Nano is to think of it as an aggregation of a whole set of focus facilities. And that's the word we're going to keep on using throughout today and on to go. Some of them are, actually all of them pretty much, are shared focus facilities. Some of those focus facilities are a little bit more guarded, only because of the need for control of materials. And hence, to get into them, there may be a couple of extra steps. But you can get into any space of MIT Nano and use it with the guidance training that indeed you need to go through. We have many spaces that are clean spaces, clean rooms. Our clean rooms are class 100. In the chases, you might find class 1000. There are nooks and crannies of MIT Nano right now that are class 1 just because there is no dust in them and not too many occupants at places. But down in the basement, you'll see metrology spaces, measurement spaces, places where you're going to have extremely low vibration, extremely low mechanical, electromagnetic noise. And up on the top floor of MIT Nano, you're going to see prototyping spaces, as well as the 3/4 of the top floor are occupied by the chemistry teaching labs that are governed by chemistry department for their teaching needs. However, they are really good partners of MIT Nano organization. Our job as MIT Nano is not to be the ones that say we have the world's best solar cells. No, no, no. MIT, Energy Initiative, should be the one to be able to say MIT is developing the world's best solar cells. We at MIT Nano should provide you the tools to make MIT stand up better, right? And their activities that are being pursued, is it at MIT, is it at MTL, at MRL, or any other entity that already so ably advances science and technology of MIT, those organizations should be able to be further enhanced because their researchers are able to step into MIT Nano to get their work done. So our job is not to be the intellectual center, but our job is to get together many, many intellectual centers of the campus to make the next set of ideas flourish. And not just what's happening on the campus, also we should be supporting the transition of ideas out of the campus. What that means, we should spend time ensuring that startups are able to be indeed accommodated, supported. Big companies, because we have a large consortium of 11 companies right now, those companies as well see a tremendous value in you, in the users of MIT Nano. Because to them, it is harvesting of the human capital and harvesting of the best of ideas that they can observe by being members of Nano that they see as a tremendous plus in their organization. With that being said, I don't want to spend much more time on MIT Nano as an organization. This meeting is aimed at giving you a perspective of what has tool-wise, instrument-wise happened inside MIT Nano? And what do users need to know as they step into this organization? So that we can give you the guidance to step through various places of MIT Nano. Very shortly, I'm going to ask Jorg Scholvin and Anna Osherov to take over this meeting. The other thing before I let them step up here is I want to make sure that you're aware that as a user community, since we do have many focus facilities, we will start organizing focus facility user updates. All of you might not care about every single focus facility, yet some of you are particularly fond of the fabbing function. That we should have as a separate meeting, as there are many, many users of the fab that have very unique needs and questions. You're welcome in these meetings to ask us specific questions. Is it about fab or anything else? We will also maybe, just in the interest of time, ask you, please postpone some of those questions for later on. Those of you who are on the webcast, because we are webcasting everything that's happening here, so I hope you don't mind being filmed accidentally if you raise your hand and ask a question. Please also use Pigeonhole. That's a pigeonhole.at with a passcode building 12 to ask questions. We're going to bring those up at the very end so that we can make sure that any questions you might have can indeed be presented. Many things are happening in MIT Nano. We are growing as an organization dramatically. We need to now make sure that as an organization we spend time telling the users where we are, because at the end, this is all in the service of you. So with that, I'm going to ask Jorg to step up, take over this discussion. Jorg and Anna are the directors of user services. The two individuals you would approach, kind of like I often say, you know, it used to be you would walk into the Apple store and go to the back to meet the geniuses at the Genius Bar, where they're the geniuses at the MIT Nano's Genius Bar. Their job is to understand everything that's happening in a building. They know a lot about how to run the tools, but primarily their job is to inform you about what you should do, how you should manage your steps through MIT Nano. But rather than me tell that, I'll ask Jorg to take over.
Sure, yeah. So I actually want to give you a little overview of what we're moving with respect to the fab. And in fact, we're moving the tools, we're moving the users, and we're also moving undergraduate students that utilize the fab. So I want to focus a little bit on those three things. Across the building, we got a couple of different floors. Obviously, the fab is in the first and the third floor is the sort of the primary components, and then packaging tools on the fifth floor that exist there as well. But before we begin, two questions for you. If you have ever peeked through the windows of MIT Nano, how many wet benches and hoods have you seen? Any guesses? Try to shout out loud. Yeah. No. If you know the answer, you can't participate. Sorry. Okay. So some people have said, what was that? 60. Okay, pretty close actually. Let me just going to turn this timer off because it's going to drive me nuts otherwise. And start thinking about my second question, which is the number of safety showers. Timings. Okay, so we're back, almost. All right, good. So this was a question actually at a different meeting. People said 12. A number of safety showers, any idea? This is probably not something you just naturally observe. Maybe every bench, yeah?
6.
6, okay. So the actual answers are 58 wet benches and 33 safety or 35 safety showers, right? And what's actually interesting about this observation is that when you're looking out or looking into the building from the outside, you generally can't easily tell these numbers. And in fact, if we look at the map of MIT Nano on level 1 and level 3, where the clean room is at, you see in green here the outline of the clean space. The red dotted line is what you actually, as an outsider, can observe looking through the windows, right? So in principle, you can see most of the lab, actually. But it's a very, very large space, as Vladimir mentioned. And so really, it's very difficult to get a full grasp of that unless you're inside the clean room. As a comparison here, also level 5 is the upper clean room part and the packaging space. And then we have the subfab in the basement that, of course, for the public, you don't actually see inside. As a comparison, next door in building 39 is where the MTL fab is located. This is the clean space in building 39, right? And so the tool move really involves a lot of the tools and labs existing in building 39, moving them over into MIT Nano. And that's kind of what we're going to focus on in the next few slides.
Are those drawn to scale?
This is drawn to scale. So equal scales gives you a rough idea of how they compare. Now, in order to get this space ready, we actually had to outfit the laboratories with a whole bunch of different things. Right? And so you can see here in kind of an overview of the amount of construction in the phase 1 that just ended this December of the first set of tools moving in from building 39 on the 5th floor. Right? So it's kind of impressive as if you're not in construction like I'm not. So I'm just blown away by the amount of 17,000 feet of conductors and 8,000 feet of piping and so on, right, for a set of tools that maybe don't really look like that on the outset, right? That's sort of similar to the wet bench count, right, where from the outside it may look like something, but when you go into the details, actually a lot of depth behind that. Now, how do we move the tools? We actually have different phases, right? So the phase 1 has just finished recently. Consists basically of a design, construction, and then a startup phase or component, right? And the startup is, of course, once the tool has moved over, bringing it online, getting people trained on it, getting it ready to go. After the startup phase, or in the middle of the startup phase, we have a sort of a +1 or plus component of the construction that allows us to address any shortcomings that may have been discovered along the way. And then we go on to the next phase. So we're now starting phase 2, which is moving more tools over from building 39. And in fact, after that, we keep going and going until everything has moved over into MIT Nano. And as Vladimir mentioned, this may take several years to do because of the volume of the equipment involved. Now, what you're seeing here actually in the different colors, those are the different funding cycles, right? So you notice that the design phase of the next component is always at the end of the funding cycle of the previous year, right? So now design for phase 1 is actually, for phase 2 is already taking place. And that allows us to make fast progress because we decouple some of the potential delays that could otherwise arise, right? The whole architecture of this is actually also important because it allows the staff to really sort of distribute their workload rather than having to disconnect tools, install new ones, and train users on new tools all at the same time. It gives kind of opportunities to bring tools online, settle things in, and then move on to the next set of tools. Now, for the phase 1 tools that we just moved, here's a couple of examples. We've moved packaging equipments, wire bonders, die saw, and so on, several metrology systems, lithography tools, thermal tools, and deposition equipment, right? Now, this is mostly equipment that came from building 39 EML, but also equipment that came from the LEAP facility in 35. So it's actually already illustrates a merging of different kind of facilities coming together. In addition to that, though, we do have these wet benches. Here are some of them, or a subset of them. And in fact, if you look at them, this is what the building came with. But if we want to use them in the fab, we actually have to make a small set of modifications still, right? So even in the phase 1 construction, we were modifying wet benches. For example, we want to have ovens, hot plate towers, spin coaters, spin rinse dryers, and so on. These are all add-on tools that really go into a wet bench to make it functional to a specific purpose, right? So this was also, again, part of the phase 1 construction, and we're ramping up these tools just as we speak now. Now, in addition to that, though, we also have some new installations, right? And a lot of these tools are relatively smaller, but they're really aimed at providing productivity, right? Whether that is just microscopes and other inspection kind of tools, a whole bunch of smaller systems, for example, for cleaving and scribing and analysis, computers, obviously gowning area, and then tools for just the staff to perform maintenance on equipment. And then a couple of larger items, of course, the MLA 150 that was just installed last week and is now getting ready, or the SAMCO RIE and ICP etchers, right? And in fact, focus on those 2 or those 3 items here as the sort of the cornerstones of the larger tools that we have in the lab right now that are actually new. Right? In addition to that, we have in the pipeline a bunch of other new tools that are coming as well, and we'll keep you informed as they're being prepared and as they arrive in the building. So in total, then we have a fair bit of equipment already in the lab. Obviously, here there's some space left for more, so we'll be able to move more equipment in as time goes on, right? So, and that's really part of the phase 2, right? Filling in the tools beyond just the equipment that we did in phase 1. Now, if we look at the space overall, this is actually not the clean space. This is a user space, right? In the space where users actually are doing work in the clean room. Just to give you an overview of where things are, the new tools that we've included, excluding the wet benches here, have been positioned, as you can see, kind of throughout the clean room. The phase 1 tool move primarily focused on the 3rd floor because a lot of the tools we've moved were relatively smaller, so they were more suitable for the 3rd floor rather than the 1st floor. On the other hand, of course, the new MLA 150, as you see, that is the first tool that actually was then installed on the 1st floor, getting ready, as well as the interference lithography system there on the bottom left. Right? So we'll be starting to migrate not just from the 3rd floor, but also migrating into the 1st floor now, and that'll pick up dramatically in phase 2. Again, these tools came from primarily building 39, and you can see kind of the locations where we pulled the equipment from here. And then phase 2 really then broadens everything and starts looking at, okay, 2nd floor, 4th floor of building 39, and really focusing on a much broader set of equipment, right? And that's in the planning now, getting ready, sort of starting the actual move sometime in the summer. Now, that was about moving tools. We've also started moving the users. In fact, we started moving the users before we moved the tools. So in some sense, we started 6 months ago in August, and we had 28 orientation sessions so far, and they're sort of 3-hour blocks where we explain to the users or the students what the clean room is, safety procedures, as well as kind of clean rooms and particles and how everything functions. And so far, we've trained about 320 users who have then access to the clean room facilities. And what's interesting is they come really from all over MIT, 19 different departments, labs, and centers, as well as 12 external companies, right? So it's really nice to see that diversity of backgrounds coming into the lab. And the final move we did was we've moved the 6152 class over as well. This was sort of a partial move. They were 1 foot still in building 39 and the other foot in building 12. And you can see some of the pictures here as they top left, and the middle one as they work in the soft lithography space. And then on the right side, in the clean room, inspecting some of the devices under the microscopes. So in the fall, we had about 31 registered students, a couple of listeners on top of that, and that's kind of the maximum capacity of the class. They came actually from 7 different departments in the fall. What they do is run 3 different modules throughout the lab, exposing them to different aspects of the clean room and the facility. And in fact, in the class, they create their own idea. They then draw their own designs and their own layouts, fabricate that, test it, and write a paper. So it's a very highly individualized kind of design project rather than a cookie cutter approach, right? And what's also interesting, similar to the users, the students actually come from many different departments at MIT over the last 2 years, 8 different ones, obviously with some departments more represented than others, but primarily sort of junior and senior level.
Thank you, Jorg. I'll move on into the metrology space. And first, I will define what is metrology at MIT Nano. Metrology at MIT Nano is an umbrella that basically encompasses all of the characterization capabilities distributed throughout the building. And we will start kind of virtual tour, continue with Jorg's presentation, virtual tour of the space and showing where these capabilities and what they are. So on the 5th floor, we have a LEAP facilities. And Dr. Anu Agarwal is overseeing the operation of these facilities. She's stewarding all the questions relating to LEAP program should be addressed to Anu. But there are characterization capabilities such as X-ray microscope in these facilities. It can be used regardless of packaging. And we just need to ask. We will show you where it is. Similarly, we have the ENI Solar Frontier Center that recently relocated from MRL to the clean space 3rd floor of a clean room. And Dr. Jeremiah Mawara is a scientist who is overseeing the mission of the Solar Frontier Center. However, Gary Riegert can help you with the shared experimental equipment that is in there. Anything has to do with glove box operation, evaporation, anything has to do with optical characterization of materials. The tool set was assembled to enable the Solar Frontier Center. However, it can be used regardless. And what I want to say is there are no boundaries between these focus facilities. The tools can be used for any type of research purpose. Immersion lab, it's outside of the clean room. It's also on the 3rd floor, and Dr. Megan Roberts is in charge of this facility, and it's basically our physical and virtual playground. It's under development. We don't know yet what it's turned to be, and Megan will update similar next week. She will tell us what is going to happen over there. But there are characterization and measurement instruments that are in this space, like a sense and motion. What I told you so far is what's metrology and where it is in the building. So what is the next capabilities that we're going to bring? What is the state-of-the-art capabilities that were not present on campus and not moved? So the first focus facility is a cryogenic electron microscopy facility that was enabled by Department of Biology, who raised the funds to bring in 3 instruments, like to bring in 2 cryogenic high-resolution TEMs to enable imaging of biological materials as well as any beam-sensitive materials on campus. The instrument that joins this trio is Aqualus CryoFib, and the tool is coming from MGH, and it's a partnership between MIT and MGH. They had no space to place the tool. We had the right conditions of humidity and vibration to enable this operation, and it's also fit very well with the whole workflow. We can prepare the sample, lamella on the fib, and then move them into the cryogenic imaging TEMs. And Dr. Ed Brainol is overseeing the operation, day-to-day operation of this facility, while Professor Thomas Schwartz is a faculty steward. Some research that's coming off these instruments, we can look at the Bob Sowers research, which is a 15 nanometer E. coli protein little rings, single particle screening analysis. We can look at the research from Professor Schwartz's lab. And in the previous image we had, and I'll go back and emphasize that Anthony Schuler and Julie McDonald are our first users on this instrument. The capability was not available on campus before, so they were very excited that they can mill their names and MIT Nano into this first grid fabricated in the instrument. The next capability is you can look at the beam-sensitive materials. So 10 nanometer gold rods or particles covered with PEG polymers, which is sensitive to beam. And this research is coming from Professor Farnaz Nuru, and she wouldn't be able to see the PEG not burning in non-cryogenic conditions. If we move on, we are continue building this focus facility, and the next one joining is a scanning and transmission electron facility, ex situ, in situ, and operando, and the name is longer than what it currently encompasses, but we are in process, we're just starting. And the first instrument installed very recently, we just accepted the tool last week, is the aberration-corrected high-resolution scanning and transmission electron microscope, and this is instrument is stewarded by Professor Jim LeBeau. And this is some of the research that's coming from that tool. We are looking at the oxide, yttrium iron oxide films. And you can see that because of the different modes that this instrument can operate, and you can see atomic layers, and you can differentiate between the light atoms and the heavy atoms. So you can basically see stack and fold with a very high resolution. How do we choose a capability? How do we know what next to bring to MIT Nano? First, we introduced the technology. So we reached out to companies and we asked, can you give us the novelty of your developments? Can you introduce the tools that you would like to see at MIT Nano that you think will complement the research that is done here? It was a difficult task. And then we asked community to come and listen and tell us what they think about all these capabilities. So since 2017, we had over 30 tool talks events. Each event was about 3 to 4 presentations and about 11 live demonstrations of equipment on campus. And then we contacted the facility, the community, and we asked you for your feedback. So what do you want to see here? What is missing? What is overbooked? What is not easily accessible? What is restricted access? And we would like to complement the other capabilities on campus, the MRL, MRSIC shared experimental facility, the ISN shared experimental facility. And we got your feedback, and based on your feedback, we moved on. So one of the most desired instruments was identified as an SEM with the capabilities of energy dispersive spectroscopy, scanning transmission electron microscopy in situ, as well as plasma cleaning and EBSD capabilities. And this instrument is incoming. We worked a great partnership with companies like Zeiss and Race and Thermo Fisher Scientific and many Oxford and many more. So they will give us the instrument for a limited amount of time. And we requested a long-term demo. So we asked for a year or longer. And we will tell us what you think about this instrument. Do you want it to stay at our campus? Do you think it will complement your research? And companies bought in, and they choose to give us those tools, and they are very confident that they have a very good instrument. This is what it tells. So this is the first instrument that is coming next month, is the SEM. The next instrument is a Race Velion Fib SEM. And here the company went beyond and actually said, we would like to promote our capability on your campus. So we will give you the instrument for 2 years to use. Tell us what you think. And we will give you the person to help you promote the capability. So they will train your users and they will operate the instrument. This tool will come as a complementary to the STEM, recently installed STEM, because we need a way to fabricate the samples. We need a way to mill the lamellae that will go into the STEM. And this instrument can do that, as well as new and exciting nanofabrication capabilities that are not available on campus currently. The next instrument is X-Radia Versa Micro CT, and this tool is coming from Zeiss. The details of this is not finalized, that's why you don't have a date here, but Dr. Charlie Seatons will be helping us overseeing the operation of this instrument with MRL. So this is a cooperation between MRL, MIT Nano, and Zeiss. If you go further, the next most desired instrument was XPS, UPS, and Raman. And if you look at the survey poll, about 70% of the responders identified that they're missing XPS capability. And this is something that we are hoping to bring to the campus, not finalized yet. So this is just some of the examples of what we are working on, and there are many more. I will not list them all. At the end of this year, this is the focus facilities that we hope to have in MIT Nano in the metrology space of basement and characterization. The user website is coming up. We have a lot of questions. How do we become users? How do we approach the instrument? Who should we contact? So we are working on this right now. In a couple of weeks, we will announce the website and few future events. Nano seminars, there are many events at MIT Nano. If you go to the MIT Nano website, you will find them all, but I'll just like to feature a couple of them. The Tool Talk series, that is next one is Anton Parr, that will come with a demo and demo of the AFM and a series of talks, and as well as the Talk Sense, which is a community update similar to this one for Immersion Lab that Megan Roberts will lead. Questions, ideas, feedback?
We want to make sure that we were not too brief, but somewhat brief, to give a fair bit of time to this meeting for you to ask us questions. So again, you can send us questions via Pigeonhole, www.pigeonhole.at, and then the passcode is building 12. And since you are in the room, there are a few people here that might have questions about whatever you've seen or other things you would want to see MIT Nano do. So I'll open the floor. And what I'll ask Jorg also to join me up here, as well as Whitney Hess, who is responsible for the safety of the building as the head of EH&S at MIT Nano. We can sit down, we can stand up. Any questions that you have? Any complaints that you have? Any praises are fine as well. You can tell me about the cookies. Did you like those? Yes, please.
Am I supposed to type my question as well?
No. If you're in the room, we'll pass the mic.
Okay. Yeah, there we go. So it's very, very exciting, and I've been watching this for some time. Our particular interest, I'm representing an MIT spin-out startup. Our particular interest is in the metrology aspect of this. And so my question would be, for some of the more sophisticated, basically state-of-the-art instruments, would a startup have the opportunity to potentially engage someone who's already trained to, operate under a limited contract to just help image material, or should the startup think about investing in, their own training up of their own employees?
So there are going to be a couple different pathways to that. Like we are currently, I don't know which instrument you refer to, but each instrument is overseen by a staff member. Yeah. So we're going to have some of assisted use capabilities, as well as it's always good to collaborate in partnership with students.
Certainly.
Definitely, if you tell me more what you would like to do, I will put you in touch with the right person.
Awesome.
The rates are going to be either assisted use or using by yourself. Price points will be different.
Certainly.
Yeah.
Great. Thank you.
Other questions? Oh, we do have questions on the screen. Let me stand over here and see if I can find some. All right. So 2 votes for this one. It says, I would like to ask if there is or will be any direct laser writing machine for lithography, which can achieve sub-micron pattern writing on photoresist using focused laser.
Well, yeah, sure. So we have the new MLA 150. That really is a 1 micron and above tool. For submicron, we're really focusing more on e-beam lithography rather than direct write optical lithography. Primarily also because of throughput, because a lot of those tools don't really give us the throughput to the optical submicron tools give us a throughput to really accommodate a larger number of users.
All right. Any questions from the room? I'm going to go back and forth. And if there are no questions in the room, yes?
I was going to ask one question about metrology. Specifically with the Cairo EM tool?
If you can repeat the question afterwards, because he's not mic'd. Please.
I can just...
Oh, there we go. Thank you.
My question is reference to metrology tools. You brought up the Cairo EM tool. That is, it's a pretty sophisticated tool, obviously. Is there a probing capability in that device? Like if I wanted to electrical probing, real time,
No.
There will never be that capability in that.
I do not believe so in the current instrumentation.
Okay.
If you're talking about the TEMs, I do not believe so.
Okay.
But on the cryo-EM side, the THEMIS, the material stem, will have in situ holders that might have these capabilities. It is not planned, but it's good to know that you're looking for.
Okay, thank you.
All right, let me just read another one. When will acid benches be operational? What is the protocol to coordinate training for acid benches?
So that actually we have just sent out an email on Sunday to the Fab users on that. They are partially being ramped up now. Probably over the next couple of weeks, we're going to have a acid bench or wet bench training session where a little bit of classroom and hands-on where people get trained on safe use of acid benches, and then as they become available, students can start using that. So pretty much over the next 2-3 weeks is kind of a gradual ramp up of that capability.
Other questions from the room? All right, let me ask a question from the board here. Is there any monthly user member fee even if I'm not active for a month or 2 in the clean room?
So I think there's a monthly fee for people because of the administrative overhead and the gowning and everything else. So I think it's a relatively small, I believe $20 a month or something like that. So that essentially exists to maintain access to the fab. There is no other fee beyond that. There's no tool charges or anything else if people aren't using the clean room.
Was there a question? Here, if you just take a mic. Grants. Front row, bottom row, middle. Are there any? I'm interested in learning how to support. Oh, okay. I'm interested in learning how MIT Nano will support research directions such as grants and or other sources of funding, existing and desired. Oh, it's a great question. So as MIT Nano, our job is to make sure we give you all the support we possibly can. There are a couple examples we can immediately cite. We launched back in 2017, before Nano ever opened. As an organization, we launched Sense.nano Center of Excellence. And we started attracting the first member companies, which gave us a little bit of cash to allow us to award 2 seed grants per year since 2017 to support Sense.nano activity. This past round of proposals, we asked for people to answer questions on sensing and give us proposals and white papers on that. We received 38 proposals. Unfortunately, given our funding at the moment, we can only award 2 seed grants out of that. Nevertheless, I'm delighted people wrote 3 to 5 pages that they really like to write and let us know about. This gave us a pool of proposals we actually passed along to our industrial partners that are considering some of those additional funding that we might be able to provide. Through NC Soft, we were able to raise money last year. Well, actually just now, we announced we awarded $750,000 in the form of 5 seed grants, $150,000 each, focused on the use of the immersive environments. The grant comes from NC Soft. Now they know themselves as NC as of December. NC is a member organization, member company of MIT Nano. They're one of the dominant software companies of Korea, South Korea. And they are very intrigued about the use of the immersive environments for education, research. They primarily make gaming, so they also are interested in use of the language of gaming for the ways that you might choose to communicate or teach or do research. What that allowed us to do is with them to develop a seed grant program. About 2 of those grants are for actually making physical technologies for the immersive environments, and about 3 are for the use of the immersive environments. These are examples of things we brought in, and we purposely ask those who fund us to allow us to distribute the funding as seed grants. Other organizations across campus, if they're writing a proposal, they can approach us and say, would you guys, if we bring in money for the tools, could you take in the tools? So an example would be, we are right now working with the APT Center. This is John Hart Center for the Additive Manufacturing, where they have developed a center. They have a number of tools that are really good for additive manufacturing that are looking for a home. That's a perfect addition to our repertoire of tools we would love to have inside MIT Nano. They would like to open it to everyone. So allow us then to go ahead and use the space in the prototyping bay. One of the prototyping bays up on the 5th floor will be indeed dedicated or at least occupied with the apt tools. Others have approached us and asked us, can you help me as I'm writing a proposal? Would MIT Nano be willing to take in the tools if any money comes in? And the answer is yes, and there are different ways we can support that. Financially, we're not rich. We're looking for any money we can get. But space-wise, we are. And space-wise, we can go ahead and accommodate, especially if you're aiming at developing a shared facility. That's our job, to make sure that the facility will be used by many. And if you were willing to roll up your sleeves, bring in the tools, we can then come up with a model by which they can be sustained through the user fees. You, since you brought it in, might become a steward of the tools, meaning you'll be a little bit extra special. We'll ask you for how to steward this facility since you brought in the tools. If they're mission critical for you, meaning this is really important for you to accomplish your work, maybe we can set up a process by which you get to sign up on the tools a little bit ahead of others so that you have a little bit of a priority access to the tools. You brought them in anyhow, right? But you certainly don't need them for 100% of the time. You have to make sure it's open to the others to use as well. So through that, we can go ahead and essentially use the amazing intellectual ability of the campus to bring the next set of ideas and next set of tool sets, enable the researchers not to have to build their own labs. Yes, you need to get the tools, but you don't have to build the labs. And maintain those tool sets to be forever fresh, not just for you, but also for the entire community. Great question. Is Nano planning to establish a database of updated baseline processes? Currently, there is none, and it's up to the users to identify and debug tool problems. Directors of user services are actually perfect to answer this question.
Yeah, so the answer, I guess, is yes, and in fact, was probably a little bit ahead of that already. Part of it is also to provide users with the ability to design their processes online, provide staff with the ability to provide demo processes to users so that new users can come in and say, okay, I want to fabricate a specific subsection of a process. They can just pick that up, start running it. And that sort of then gives us the opportunity to also bring in baseline processes, right? Because every little public module that is generated by the staff or potentially by other users and super users becomes essentially a good anchor point for a baseline process, right? Because you can attach to that expectations of what the process should result and observations of what actually has happened over time, right? So I think that sort of integration with the online process building and process checking capabilities really allows us to very comprehensively bring in baseline processes into that picture.
I'm going to choose the one on the right only because I want to make sure Whitney also answers the question for us, which is, can we make the 24-hour physical body requirement much more flexible for safe processes?
Yeah, we actually made it quite a lot more flexible compared to some other labs. We did a risk assessment of all the activities that occur in the lab and identified the ones that are the most hazardous or the most risk to the users. And that's the only instance where you would be required to have a physical buddy. All other low-risk activities you could do on your own. Even though we encourage you to have a buddy, you could potentially do it alone.
Okay. Other questions from the room? Yes. There's a mic right behind you, sorry.
I guess this would go to Jorg. How do you sign up for that email list that you send out monthly?
It's, so that goes actually to all Fab users. So if you're a Fab user or you're a user at Fab.nano or a Building 39 Fab user, that automatically goes out.
And if you're not?
Then you can become a Fab user.
Or just make sure you let Jorg know.
That too.
If you ever have a question about MIT Nano, you don't feel like you know whom to email, just send an email to mitnano@mit.edu. I'll repeat, mitnano, one word, @mit.edu. And that is a general inbox. We read every single one of those. We spend our time answering questions on it. Our communications director, Tom Garrity, has a note on this as well.
Yeah, a lot of what Jorg sends out to the Fab users, we then post to the MIT Nano main site. So if you go to our news section, there is a category of updates called facility updates. And a lot of what Jorg shares with the user community, where it's relevant, we repost that so it's available to anybody who comes to the website.
The second email address, if you're really, really in trouble and you feel like you need to include the word help in your email, the email address nanohelp, is that right? Nanohelp@mit.edu. Again, nanohelp is one word. That's one that, it reaches the same people as the MIT Nano at mit.edu. I'm just saying, if you just feel like you need word help in your email address, please use that second one. We are responsive, I think. You'll find us relatively quickly. We'll get back to your problem. What we do is we triage the questions appropriately to the staff, and then the staff responds back. Let me see. Any other questions from the room? In that case, let me find more from the board. Is there a plan for reaching out to users that have left MTL for Harvard CNS? Is there a measure of how big this pool of potential Fab users is? I'm going to start answering that question, and then I'm going to ask my colleagues to answer it back. We are delighted that we have such a great partner organization in the form of Harvard up the street. In many ways, they supplement when we are in a crunch time. The one reason why we built MIT Nano is because we realize how long you have to wait sometimes for some of the instruments on the MIT campus. It's not that we don't have the instruments, we do. We have just as many instruments as any other campus out there. It's just that the need that we have on the campus for managing nanoscale, imaging nanoscale, processing nanoscale is so much larger than any other campus you ever encounter. Result of it is that we are just absolutely delighted that our colleagues at Harvard have the tools for our overflow need. With MIT Nano, I think you're going to start seeing that those tools become more available on the campus as well. And as a result, you might find yourself not needing to take the train up the street. It's your choice. We want to make sure you get the best possible experience. If you feel like the bucolic nature of the Harvard campus inspires you, and consequently, the half-an-hour trip to there and enjoyment of the local environment is really good for you, please do that. We don't want to stop you from that. On the same end, we have, I think, built MIT Nano to be bucolic enough. With a courtyard and birches on one side swaying in the wind and the breezeway decorated with artwork. Hopefully you find in it an inspiration that you were otherwise getting in the way that Harvard has maybe given to you. We, again, so the windows? Well, yeah, you can actually look into MIT Nano. You can look into the Harvard ones. You kind of have to really, yeah. Well, so if you are inside MIT Nano, yes, indeed, you'll be able to see the outside world in a little bit different way. We are not competing. You should make sure you get your work done the best you can. And so as an organization, we as MIT Nano should give you what you need. And if you don't, please let us know. And we'll see if we can afford it. I mean, that's the, that's the bottom line of it, because it's going to take time to fill a space this big, right? We estimate it will be on the scale of $150 million or more of tools that will need to move into MIT Nano. If you have a check to give me one of those, please let me know. And we'll be able to start moving the tools much more rapidly in. Any other questions from the room before I go back to board? All right. Is there a plan for adding tool training to the website or Coral?
There is. I think I'll just stop here. There is.
Okay.
It'll take a little time, but we hope in the next months you will see that this capability exists.
Well, do you want to just tell us how do you register? I mean, Atlas, I guess I'm trying to point to.
Yeah. So right now we have the way to register. You contact the person and you get trained. It's not, but there is no centralized offering of the training, and we are working on that. It's going to be through the MIT Atlas Center, and we already have a safety training and orientation training that are posted through that way. We will add the tool-specific trainings to that platform in the near future.
Okay. The next question that says, what's the estimated time of arrival for the process cooling water? So the answer to that is there is process cooling water that's localized inside MIT Nano. One of the, the building is a very complex building, and 99.9% of the 4,000 systems of MIT Nano work absolutely perfectly. It took us a year to get rid of most of the alarms. That building has more alarms than the rest of the campus combined, I'm told. But what this also simply means is that not everything is always perfectly done. It doesn't mean it's an issue. It just means that we right now do not have a centralized process cooling water system. We are getting it up and running. We sorted it out. Despite the fact we don't have a centralized system, we have installed a set of localized systems for process cooling chilled water. It's an issue as more and more tools are coming in, but ones that we are managing together with Department Facilities. So at this from perspective of a user, I don't think you have to worry about our process cooling chilled water. That's our thing to worry about. For you, it should seem seamless. I gave you more information that you really should worry about. We don't mind telling you anything you want to know about MIT Nano. But at the same time, there is a minutia of details to operate and stand up and manage the facility that really none of the users should ever have to be exposed to, unless you're really aficionado of HVAC systems, high efficiency opportunities, and so forth. We are, in due time, going to write, I think, a little paper or a little booklet that talks about how MIT Nano is constructed, only because we have incorporated about 70 environmentally benign solutions into the building that are typically not found in a building. That also gives us a very high credit marks towards a LEED certification of the building, which hopefully in due time we'll be able to tell you more about. But again, those are the things you really shouldn't as users be focused on. Tell us what tools you need. And our job is to run the building. Tell us if you don't like the temperature, right? And we'll adjust things. Tell us if humidity is too high. Those are the things we want to hear from you, from perspective of your processes. And we'll be able to go ahead and adjust whatever is needed to make your processes work for you. Don't bring in anything radioactive, please. And any pathogen that's like BL3, please don't bring those. But everything else, we'll consider. Okay.
I'll echo that, Vladimir.
Okay. What is the limiting start of phase 2 move? We are in a process of phase 2 move. So I'm here looking at Nick Nonos. He is the director of infrastructure for MIT Nano. Do you want to just make a few comments on what phase 2 is? What's the schedule of it, and how are we looking?
Sure. So I think, is this working? Hello?
Yep.
Yeah, so I think what is limiting phase 2? I think really in order to leverage economy of scale and doing things one thing at a time, we're trying to aggregate equipment into these phases, as we call them. So I think that's one constraint, is just trying to make sure that we're checking all the boxes, checking with every tool owner, as well as kind of giving time to aggregate these projects across campus. So if there's an incoming faculty member that has a project or some other private user, trying to get them all into one coherent project. So that's kind of one piece, is economy of scale. I guess the second piece is just funding in general. So obviously, come June is when the fiscal year ends and the turnover there. So again, trying to consolidate things and executing them in a single phase.
Yeah, the one thing that we didn't spend much time on, but it takes the brunt of Nick's time, Dennis Grimard's time, the managing director's time, is to think about what is it that we can do to make as rapid of a move as possible. Every tool installed inside MIT Nano, we do detailed drawings of prior to it ever moving into MIT Nano. So that from the detailed drawings, we can in detail figure out where the plug should be installed. MIT Nano looks amazing from the outside. It's a very pretty place. When you step on the inside, it also looks amazing. But one thing you'll notice, in every single bay, there are no electrical plugs. There's no piping. There's nothing there. I mean, the reason why we installed 3.3 miles of electrical wiring in phase 1 is because there's nothing there. It's a shell of a space, purposely built that way. We also installed about 1.3 miles of piping in phase 1 because that's on purpose. We didn't know where all the tools will be, and it would have been wasteful to wire and pipe the space knowing we'll have to rip everything out and redo it. What that means is in these phases, we do detailed drawing of the actual tool and where it's going to be positioned, how it's going to be positioned. And then next thing that happens is that in a matter of a week or two, it will take to dismount it out of the existing building, like building 39, and move it across the courtyard and replug it in exactly existing slots that are perfectly geometrically positioned for the tool to be accepted extremely rapidly, hence allowing for minimal downtime for the operation of the tool. If we found the tool is particularly critical, like the MLA 150, we decided to buy the second one so that we can go ahead and have an MLA 150 operating in MIT Nano as we are dismounting it from MTL. Because if that tool is not up in building 39, that would be a really big deal. So you have a way to indeed transition without us affecting you. User experience to us is paramount. And user experience, we are working extremely hard both in bringing new staff in to help us with additional tool sets and making sure that the present staff that is stretched as they have to go between the buildings as they're transitioning to meet the needs of users in both Fab 39 and Fab 12 are indeed being able to be supported as we do that transition. So we're doing our very best, but we also love to be alerted for the things we're failing on. After all, the reason why we started these meetings is to make sure we get your voice in the discussion, as opposed to us just marching forward with all the knowledge we have. This is the best way for us to gather additional information we need, at least. If you have additional ideas on how we can collect more information, please let us know. So let me see, is there, when will the vacuum deposition system be installed? New tools, also legacy tools at MIT.
So I think we've had, if you look at what's currently already in operation in Fab.nano, we have 2 AJA, 1 sputter, one evaporator tools. Those have been moved over from building 39. In addition to that, we also have a brand new Samco P CVD for oxide and nitride deposition. So there's some examples of what already has moved either as new tools or as legacy tools. And of course, in phase 2, then we're going to approach a lot of the other deposition tools still currently in building 39. So I think we're kind of in the middle of that right now.
So Anna, also in the nanostructure material set, the Solar Frontier Center facility has deposition tools for vacuum deposition.
Yes, there is a 2 thermal evaporators that's relocated. They are capable of processing samples that require inert processing, not the materials. So we cannot do lithium depositions, unfortunately. But this is something to think about. Like, this is just one of the requests that I received recently. Someone looking to deposit lithium, and that we might address in the future. But if you need an inert processing, these evaporators are available. In this
if you need to deposit organic thin films, if you need to deposit anything that's evaporatable and not poisonous, we are able to process, and you can do it in the inert atmosphere of glove boxes. So as an example, larger samples are about 4 inches in diameter, although they're squared, so however you wish. So the last question I have up here, any last questions from the audience? No, so I'll just read the last question from the board. Are there any efforts at the pico level? Of course. The answer is, of course there are. We work at 1,000 pico level all the time. The unit of nano was chosen because that is the distance between atoms that make solids. Fraction of nano, right? 0.1 nano, few angstroms, is the typical distance between atomic scales. You can call that pico if you wish. The way we think of our responsibility is to build anything from atoms up. We really don't think of too hard about how to deal with the atoms down. That's our colleagues in nuclear science will gladly make tools for our colleagues in nuclear science so they can then take the next set of explorations. MIT Nano has really no limits, and if it only goes as far as your imagination goes. If you have ways of telling us how to reach that picoscale in a scalable fashion, please let us know. We'll take you in. We have plenty of real estate to take those next set of ideas. Thank you very much for right now. We look forward to seeing you in a month or so. We'll announce another one of these. And as I mentioned, we will start sub-meetings of the focus facilities. Hopefully, in the multitudes of those meetings, you'll find yourself being able to say what you want to tell us. And if not, email us. You can do it anonymously, or you can do it indeed in person. We'd love to hear from you. Thank you very much.